Hello, students. Right here again today. We got notes from the book on section 10.4. I'll go through the PowerPoint. You should have read the section. Just going through the PowerPoint, reading the section, listen to my video. You can add any other notes that you may not have encountered during the Hummer notes. In 10.4, things you should be understanding are our objectives: explain what is meant by the percent composition of a compound, determine the empirical molecular formulas of a compound from mass, percent, and actual mass data. Percent by mass, I'll review vocab from earlier chapter. Ratio mass of each element of compound, total mass expressed as a percent. New, we get percent composition, empirical formula, and molecular formula. Molecular formula of a compound is its whole number multiple of its empirical formula, our main idea for this section. Here's a percent composition. Percent by mass is found by dividing the mass of the element by the mass of the compound and multiplying by 100. And there's a little formula. I typically won't put in this times 100. I find it to be a little more confusing than necessary. Just have to remember to express it as a percent. As you're thinking percent, an old thing you should remember, percent is part divided by whole. The percent composition is the percent by mass of each element in a compound. And percent by mass, another formula here. Boom. Percent by mass, mass of element in 1 mole of the compound divided by the molar mass of the compound. Again, I'll leave out the times 100 when I do it. So sometimes we'll figure it from its chemical formula, sometimes we'll figure it from experimental data. Empirical formula is the smallest whole number ratio of the elements. And when we calculate the empirical formula, we assume we have 100 grams, and that way the percent can just become grams. We can presume any amount, but by using 100 grams allows us that percent to become grams. And in class, we will do or have already done a number of this type of problems. So, empirical formula, molecular formula may do difference. Here's an empirical molecular formula for hydrogen peroxide H2O2. The empirical formula is HO. The molecular formula tells the actual amount of atoms in 1 molecule or formula unit of the substance. Molecular formula is always a whole number multiple of the empirical formula. And here's a little flow chart. If you like flow charts, put it in your notes if it helps you. If flow charts really don't help you that much, don't put it in. And empirical formula for compound C12H6O2. Here we notice a 6, a 12, and a 6 for subscripts. So we'll all divide by 6. 1, 2, 1, and that's why it's C over here. And empirical formula for hydrogen peroxide, had that in our notes. The molecular formula for hydrogen peroxide, H2O2. The 2's will both divide by 2, giving us a 1 and 1, why the HO. So, real quick overview, maybe review over section 10.4. So, that's it for now. Till next time, Strite's done.